So in this video we will talk about the determinant test for the congruency condition. So if we have three lines, let's say aix plus biy plus ci is equal to 0, and for line 1 it is a1x plus b1y plus c1 is equal to 0. Similarly, for I is equal to 2, we have a2x plus b2y plus c2 is equal to 0. Similarly, for I is equal to 3, so I will write I is equal to 1, 2, 3. So we have three different equations. So if you have three different equations, then the concurrency occurs when the determinant of the coefficients is 0. So for the first so the first column is the first coefficient a1, a2, a3. I can say a1, a2, a3, the first coefficient, the coefficient of x for all of the equations. So the second column is the coefficient of y, should be b1, b2, b3, and the third column should be the constant values c1, c2, c3. So if this determinant is 0, then we can say that the lines are concurrent. Okay. So next we have fundamental principle. This principle says that if you have 3 points xy and x1, y1 and x2, y2, then those points are collinear if and only if their determinant is 0. The determinant is x, y and 1. Similarly, x1, y1 with 1 and x2, y2 with 1. And if this determinant is 0, then we can say that all of the 3 points are collinear. So now we can have an example. So in this example, we have to find the line equation through 2 points using the determinant method. So what is the determinant method? We have just studied the formula. This is the formula. Let's look. So we will use this formula to find the equation of line. So this is the formula. 2 points are given. x1, y1 is this. x2, y2 is this. So we will put these values in place of x1, y1 and x2, y2. If we put these values, we will get this determinant. Okay, and if you expand this determinant along the first row, then we can have -1 to the power 1 plus 1 for the first value, because it is in the first row and the first column, times x, times deleting this column and deleting this row, we have this thing. So this thing should be written here. And then for y, since y is in the first row and the second column, so I will write -1 to the power 1 plus 2 times y, and deleting this column and deleting this row, we are left with this and with this. So I will write these as a determinant, and for this value I will write -1 to the power 1 plus 3, because this is in the third column, in the first row and the third column. So I will write 1 plus 3. So if I delete this and this, I will left with this. So I will write this as a subdeterminant, determinant of the submatrix. If we calculate the first value, this is 1, because -1 to the power 2, which is even number. So -1 to the power even number is plus, so nothing should be written. Then x, and the determinant of this is 2 times 1 is 2, plus 4. Okay. The next value is -y, because this is minus, because -1 to the power 3, which is odd number, so that's why I will write negative. So negative times y, and the determinant of this is 1 minus 5. Similarly, negative 1 to the power 1 plus 3, which is 4. So it is even number. So I will write plus. So plus 1 times this determinant is minus 4 times minus 10. If I simplify these values, I will get 6x plus 4y minus 14. But in this equation, you can take common 2 from all of the values. If I take common 2, it will become 3, it will become 2, it will become 7 because 2 is taken out from each value. And since this is the product of two numbers, two things, this is the first value and this is the second value. If the product of two values is 0, then we will say that either of the value is 0. But we know that 2 is not 0, so that means this is 0. Hence we can say that the inside thing is 0. I mean 3x plus 2y minus 7 is 0. So this is the equation of line which is required. Now let's do an exercise. In this exercise, you are asked to check whether the 3 points are collinear or not. So here is the solution. In order to check the points are collinear, we have to find the determinant. If the determinant is 0, then the points are collinear. Otherwise, no. The determinant, in the determinant, you will write here 1, 1, 1. And here you will write the first point. Here you will write the second point. Here you will write the third point. You can check the first point is minus 2, 1. You can check here is minus 2, 1. And the second point is 7, 7. And here we have 7, 7. The third point is 1, 3. So 1, 3 is here. So we will find this determinant. If it is 0, then the points are collinear, otherwise not. How to find the determinant? So let's expand it using the first row. So for the first row, for the first value, it is, you can check it is in the first row and the first column. So I will write negative 1 to the power 1 plus 1 times negative 2, this value, times the determinant. After deleting this column and this row, we can have this determinant. And for this value, I will write, because this value is in the first row and the second column, so minus 1 to the power 1 plus 2 times this 1 times the determinant is, by deleting these two things, I will have 7, 1 and 1, 1. Plus, for this value, I will write negative 1 to the power 1 plus 3 because this is in the first row and the third column. So I will write 1 plus 3 times the determinant after deleting this and this determinant. So I will write these values. So after simplification, you will get these values and at the end you will check it is 0. So since this is 0, so you will say that the points are collinear. Now there are some special cases. So the first special case is when you have 2 points and those points are vertical. For example, A0 and A1. This is the scenario. For example, this is A0 and this is A1. So they are vertical. So if this is the case, then we can find the equation, their equation of line, which is called the vertical line. The equation of line can be found by the determinant method in this way, because x, y, 1 and these ones are coming from the formula, and this is the first point and this is the second point. Here you can check first and second point. So using these points and the determinant method, we can find the equation of vertical line. If we expand this determinant along the second row, because second row has a 0, so if we do expand the determinant along the second row, then for this value I will write negative 1 to the power 2 plus 1, because A is in the second row and the first column, so I will write 2 plus 1 times A times the determinant of the submatrix obtained by deleting this row and this column, which I have y1 and 1 1, again plus I will write this 0, because this is 0. I will not write the other values, and then for this value I will write negative 1 to the power 2 plus 3, because this is in the second row and in the third column. So I will write 2 plus 3 times 1 times the determinant obtained by deleting this row and this column. Okay, so we put it equal to 0. Then after simplification we will get this value, and after more simplification you can check. I can cancel ay, negative ay with positive ay, so I will end up with a minus x. So if I take a to the other side, you have x is equal to a. This is what we study the equation of vertical line. So there is another special case 2. This is the special case for the horizontal line. So if you have 2 points which are lying horizontally, for example, this is the case b 0b, for example, this is a point 0b, and 1b, this is the point. You can check these points are horizontal. So if this is the case, then we can still use the determinant method to find the equation of horizontal line. This is coming from the formula, this is coming from the formula, and this is the first point and this is the second point. The first point was 0b and the second point was 1b. So I have put 0b and 1b. And if we expand this determinant along the second row again, because the second row contains a 0, so the first value is 0 because this is 0. So I will go to the second value. Since this is in the second row and the second column, so I will write negative 1 to the power 2 plus 2 times the determinant of the submatrix obtained by deleting this row and this column, which is x1 1 1. So x1 1 1 plus this value, which is 1, and it is in the second row and the third column. You can check second row and the third column. So I will write negative 1 to the power 2 plus 3 times the determinant obtained by deleting this and deleting this. So if we simplify these values, we will get this result. So in this you can check that bx is cancelled by negative bx. So you will have negative b plus y equals 0. So if you take y to the other side, you will get y is equal to b. This is exactly the equation of horizontal line.